In this video, I'm going to show you how to solve a quadratic equation by completing the square. Now, you've already learned how to solve a quadratic equation by factoring and graphing. However, factoring is not always possible, and graphing does not always give exact solutions. However, what you do know how to do is to change a quadratic function, which is expressed in standard form, where y equals ax squared plus bx plus c, to vertex form, where y equals a times x minus p all squared plus q. And you do this by completing the square. Now, once you have the quadratic function in vertex form, then you can solve for the roots by using the square root principle that you learned before. So let's take a look at an example. Here we have x squared minus 8x minus 20 equals to 0. We want to complete the square with the first two terms. So we have x squared minus 8x, and we need to add a number and then also subtract it so that we maintain the 0 property. And the number that we have to add and subtract is half of negative 8, which is negative 4, and we square that, and that's going to be 16. So we add 16, and we subtract 16, so that this second line of equation does equal the first line, where really and essentially we're adding 0. So we're going to factor from these first three terms, and this gives us x minus 4 all squared. And then we're going to combine our last two constants together to give us negative 36, and that equals 0. So move 36 to the right side to give us positive 36. And now we're going to square root both sides. And don't forget that when we square root both sides, we get a positive and a negative answer, where the square root is on the side that does not have the variable. So now we have x minus 4 equals to plus or minus, and then we can square root 36, and that is 6. Add both sides, we're going to add 4 to both sides. So we have x is equal to 4 plus or minus 6. Now the plus or minus, remember, it belongs to the 6 and not to the 4. So what we can do here is we can actually solve for the two values. So we say that 4 plus 6 will give us one root, and then 4 minus 6 will give us a second root. So we're going to solve these little equations here. 4 plus 6 is 10, and then 4 minus 6 is negative 2. All right, to review what I did was I completed the square by taking the first two terms and then adding 16 and subtracting 16, which will then give me a trinomial in the front, which I can then factor to be x minus 4 all squared. And then I took the constant values and I subtracted them to get negative 36, which I then moved to the right side. And then I solved by using the square root principle. Now, what I want to do is to show you another way to do this. So I'm going to rewrite this over here. X squared minus 8x minus 20 equals 0. And what I'm going to do this time is a little bit different. So I'm going to actually move the negative 20 to the right side right away. So I'm going to move my constant to the right, and I get 20. So what I want to do is now complete the square on the left side. So same process. I am going to half negative 8, which is negative 4, and I square that, and I get 16. So I'm going to add 16 to the left side. Now, if I add 16 to the left side, to maintain the equality, I also need to add 16 to the right side. So now what I can do is factor my left side, and this factors to be x minus 4 all squared. On the right side, now I have equals to 36. So this, you can see, looks just like this step over here. The only thing is that I moved the constant over first, and then I completed the square. Now, I kind of like this method because my constant's already moved over to the right, which I know that I have to do anyways if you look at this step over here that I did on the left side. So same as before, I'm going to square root both sides, so I get plus or minus 6 on the right. Move my 4 over, so I get 4 plus or minus 6. And then I get x is equal to 10 when I go 4 plus 6, and then 4 minus 6 is negative 2. Let's take a look at 2 other examples, maybe not so nice ones. And these ones are not as nice because you can see this first one has an odd number as its coefficient for the middle term, and the second one has a coefficient in the front. So let me show you how to solve these ones. So for this first one here, we are going to do the same thing that we did before. I like to use the second method, so I'm going to move the 9, or the negative 9 to the right side, so it's going to become positive. And now I'm going to complete the square. So take 5, and then half of 5 is 5 over 2. And then we're going to square that number, and that gives us 25 over 4. So if I add 25 over 4 on the left to complete the square, I also need to add 25 over 4 on the right side to maintain the equality. So on the left, I'm going to factor. I get x plus 5 over 2, close my bracket, and that's going to be all squared. And then on the right side, I need to get a common denominator, which is going to be 4. So this, we can write it as 9 over 1 times 4 on the top and bottom. So I get 36 plus 25 all over 4. And let me just rewrite my left side. So on the right, I get 61 over 4 when I add 36 and 25. Square root both sides. Don't forget the plus or minus on the side without the variable. So I get x plus 5 over 2 and plus or minus root 61, which I cannot square root, but I can square root the 4 independently on the denominator. So that's going to be 2. Now, if you actually always do this correctly and properly, the left side and the right side will always have the same denominator, as long as you don't actually simplify the right side. So when I move my 5 over 2 to the left, to the right side, I get negative 5 plus or minus root 61, and then all of this will be divided by 2. And like I said, if you don't simplify the right side, in this case we can't, but sometimes you can. But if you don't simplify it, the denominators will always be the same, and when you move the constant number on the left to the right, we can just join the fractions together. So let me show you what to do when there is a constant in the front. Now, unlike the ones when we're completing the square to change from standard form to vertex form for a quadratic function, when we're solving, what I'm going to do to make it easier, because I'm solving for x, I'm going to divide every term by 2. Now, when I say every term, I mean every term on the left side and the right side. So what I get when I do this is I get x squared. So it's 2 divided by 2 is 1. And then I have 7 divided by 2, so I get 7 over 2x. And then plus a half, and that equals 0. Okay, so now I'm going to move my constant, excuse me, of half to the right, so I get a negative a half. And then I'm going to complete the square on the left. So I'm going to take my 7 over 2, and remember I have to half that. So that's going to give me 7 over 4. And then 7 over 4 needs to be squared, so I get 49 over 16. So that is the number that I'm going to add to my left side and also to my right side. And on the left, I'm going to factor. So this becomes x plus 7 over 4, all squared. And on the right, I'm going to get a common denominator, which is 16. So times top and bottom by 8. And get negative 8 plus 49 all over 16. So rewrite my left side here. And negative 8 plus 49 is 41 all over 16. Now we are ready to square root both sides because we just have a binomial squared on the left. Don't forget the plus or minus. So I have x plus 7 over 4 equals to plus or minus root 41, which I cannot square root, but I can square root 16. which is 4. And notice again, I have both fractions that have the same denominator. So when I move the 704 to the right, all of this will be over the number 4, which is in the denominator. And this is how you solve by completing the square.